Hi! Good day everyone! Sa videong ito, pag-aaralan natin kung paano mag-solve ng higher order homogeneous linear differential equations with constant coefficients. Basically, yung pag-aaralan natin ngayon is just an extension of what we have learned from the second order homogeneous linear differential equations with constant coefficients. So, ang pinagkaiba lang nito doon sa lesson na yon is that yung degree nung, or yung order ng differential equation natin can be higher than 2. Okay, so ito yung tinatawag nating higher order homogeneous linear differential equation with constant coefficients. Etong mga a's na yan are just numbers or just constants. Of course, equal to 0 and they are linear in the derivatives. Yung nth derivative and minus 1 derivative, etc. And of course, kailangan ulit natin for this video is the auxiliary equation or the characteristic equation wherein you just replace the nth derivative by m raised to n. Tapos, yung y, you replace it by 1. That's why you get this characteristic equation. So, para magets natin yun, let's do this example. Let's say we have this homogeneous linear differential equation. So, its auxiliary equation is m raised to 5 minus 6m raised to 4 plus 2m square minus yung y, you replace it by 1 equal to 0. So, ganun lang yun. Notation lang yun. Pero kakailanganin natin yung auxiliary equation to find the general solution. And let me just introduce you with some notations. So, we know that the nth derivative of y with respect to x is written this way, right? Or nakaganito, y to the n, but you have that parenthesis. So, meron tayong tinatawag na differential operator d. And if you want to write this one in terms of the differential operator, that is d to the n of y. Ibig sabihin nito, the nth derivative of y. Okay. So, hindi niya sinusulat dito ano yung independent variable mo, and that's okay. So, mamaya, malalaman natin anong silbi niya, bakit sinusulat pa natin siya ng mga naka-letter D or naka-differential operator. So, let's isulat natin itong binigay sa atin in terms of our D. So, magkakaroon tayo ng D to the N of Y plus A sub N minus 1 tapos dito the n minus 1 of y hanggang umabot ka dun sa a sub 1 d of y tapos plus a not y equal to 0. And then you can factor out y. Ang reason for this is that ang differential operator ay isang linear transform. Okay. I mean, ito ang goal ko lang naman dito is to explain bakit naging ganun yung notation at bakit siya useful in our case. So, useful siya in our case kasi as you can observe, etong differential equation na to can be written in this manner, right? So, you have yung mga linear combinations ng mga d to the n times y equal to 0. Pero derivative talaga yung nire-represent nito, diba? Pwede mo siya isipin as parang polynomial lang wherein you just distribute your y, ganyan. But more importantly, kung makikita ninyo, anong connect nitong dalawang to? Ang connect nilang dalawa ay yung auxiliary equation na sisilip mo na agad from here. So, you just replace d by m, then you get, and equate it to 0, you get the auxiliary equation. Okay? And kung magtataka kayo sa ibang books, ganito nila sinusulat. So let's say let L of x be this polynomial, x to the n plus an minus 1, x to the n minus 1 plus a1x plus a naught. Then, yung original na differential equation natin, which is this one, can be written as if you plug in d here, you get this, right? So L of d tapos your y equal to 0. Kaya minsan sa mga books or pag nag-aral kayo on your own, iba sasabihin nila, this is homogeneous linear differential equation with constant coefficients where L is an nth degree polynomial. Okay, so minsan ganun nila sinasabi. O yung iba naman, nakaganito, nila sinusulat. Or minsan, nakaganito. Okay, but the point is, pare-pareha lang sila. Magkakaiba lang sila ng way sa pagsusulat. At madalas ginagamit itong naka-notation na letter D para kasi pag pinalitin mo yung D ng M, makukuha mo agad yung auxiliary equation. Okay, so, pero interested tayo sa auxiliary equation because from the auxiliary equation, makukuha mo yung general solution ng higher order homogeneous linear defect with constant coefficients. Haba ng name, okay, that's normal. Okay, so going back, so we have this defect, this differential equation. At kunyari, you have the auxiliary equation. Just like what we did in the second order case, you compute for the roots of the auxiliary equation. So let's say you have a root na itago natin sa pangalang R. Let's say its multiplicity is K. Okay, so ibig sabihin ng K kung ilang beses siya lalabas doon sa root ng auxiliary equation mo. Okay, so ganito. So isa-isahin natin . So you have case 1. We only have 2 cases. And the first one is this. If R is real with multiplicity K, then etong mga bagay na yan, ilan sila? K sila, are linearly independent solution for your differential equation star. Okay, so ano yung nangyayari? E raised to root times x, tapos kokopyahin mo lang to, pero ta-times mo sa x. In next one, ta-times mo lang ulit sa x. Ta-times mo lang ulit sa x. Okay? So, etong mga bagay na yan are linearly independent solutions to your differential equation. So, magiging bahagi ito nung general solution. So, mamaya ipapakita natin anong itsura. Okay? And for the second case, if a plus bi and a minus bi are roots of the auxiliary equation, so we are assuming here that the auxiliary equation has real coefficients only. Para mangyari na palagi magka-partner yung a plus bi at saka a minus bi as a root. And yung multiplicity nila the same. So kung k times itong lumalabas as a root, k times din ito lalabas as a root. Okay? So itong napakahabang thing na to, form linearly independent solutions to star. Okay. So, observe lang natin para hindi siya masyadong masakit sa mata. So, anong nangyayari? Yung pinakauna, you start with e to the ax cosine bx. Then the next one, you just multiply it by x. Multiply it again by x. And then you multiply it by x hanggang umabot ka dun sa dulo, dun sa ang exponent is k minus 1. So, paano mo malalaman kung magsa-stop ka na? Kailangan pag binilang mo to, k lahat sila. And then you do the same thing with sine. So, e raised to ax sine bx, you multiply by x, you multiply it again by x. Okay, hanggang umabot ka dito. And then you stop kapag k na silang lahat. Okay. So, paano yung magiging general solution natin? So, gagawin nyo tong case 1 and case 2 for each root kung saan siya nag-a-apply. So, magpoproduce yan ng mga ganito. So, marami siyang ipoproduce. So, yung general solution will be yung linear combination niyang yung maraming bagay na yan. What do I mean by linear combination? So, C1 times this, plus C2 times this, plus C3 times this, plus CK minus 1 times this. Lalagyan mo lang lahat ng mga iba-ibang constants, yung mga solutions na yan, and then you add them all. So, that is the general solution. Okay, so let us try to solve this a homogeneous linear defect. Of course, we get the auxiliary equation first. So, the auxiliary equation is m cubed plus 3m squared plus 3m plus 1 is 0. Okay? You can actually factor this one as m plus 1 cubed. So, yung m plus 1, tatlong beses yun, no? Or m is equal to negative 1, pero ilang beses? 3 times. Okay? So, ibig sabihin, the multiplicity of negative 1 is 3. So, yung negative 1 na yan will give you an linearly independent solutions na ang itsura ay e raised to yung root mo times x. So, nakuha mo na yung una. Ito times mo na lang by x yan. And then multiply it by x again. And then you stop kung yung dami nila matches your multiplicity. So in this case, our multiplicity is 3. So you should have 3 linearly independent solution. At siya lang naman yung root mo, negative 1. So from there, makukuha mo na yung general solution. So the general solution is y equal to c1 e raised to negative x plus c2 x e raised to negative x plus c3 x squared e raised to negative x. And as you can observe, ang ginawa ko lang, naglagay lang ako ng c1, c2, c3 dito, and then inad ko lang sila. Okay, for our next example, we have this homogeneous linear differential equation. But in this case, ang notation niya naka-letter D siya. Ibig sabihin nito, you just square this polynomial. Paano ba to? So, ganun lang ulit. So, we find the auxiliary equation first. Diba auxiliary equation, you just replace D by M. So, we have M squared minus 2M plus 5 square. Okay? And then, equate each factor to 0. M squared minus 2M plus 5 is 0. Kahit isa na lang i-compute mo, tas doblehin mo yung bawat root kasi pareha lang ng lalabas yun doon. Okay, so we actually use the quadratic formula. Negative b plus minus square root ng b squared minus 4ac all over 2 times a. So, ang m natin, 2 plus minus, ano na yan? 4 minus 20, negative 16 over 2. Square root ko, alisin mo yung negative, dun sa square root ng negative 16, maging square root ng 16, maglalagay ka ng i sa labas. So, 2 plus minus 4i over 2 equal to 1 plus minus 2i, right? So, kapag kinompute mo to, ito rin ang lalabas. So, ano yung mga roots mo? So, 1 plus minus 2i, tsaka 1 plus minus 2i. So, mag-a-apply dito anong rule? Itong case 2 natin, no? So, yung multiplicity ng bawat isa nung may plus tsaka minus is k. In this case, ang multiplicity ng 1 plus 2i tsaka 1 minus 2i ay parehang 2. Okay, so note, k is equal to 2. So, apply natin si case 2. K is equal to 2, A is 1, B is 2. Okay? So, ito yung B natin, ito yung A natin. Okay? So, yung linearly independent solutions na mapoproduce nito ay e raised to ax cosine bx. Tapos multiplicity 2, no? So, x e raised to ax cosine 2x. So, dalawa for cosine, tapos dalawa rin for sine. Oops, sine na siya. Okay? So, for the general solution, lalagyan ko lang yan na C1, C2, C3, C4, and then add all of them. So, y equal to C1 e raised to x cosine 2x plus C2 x e raised to x cosine 2x plus 3 plus C4 x e raised to x sine 2x. So, ito yung general solution na hinahanap natin. Okay? So, dun sa first case natin, meron tayo puro real lang na umuulit. Dito, puro non-real na umuulit. So, paano yung kapag yung roots ng auxiliary equation mo, mix-mix na may mga real na umuulit, may non-real na umuulit, etc. Okay, so this is our third example. So, ito real pa rin ata to. So, mamaya na yung nag-mix-mix. Pero basically, pare-pareha lang ginagawa natin. Okay, let us find the auxiliary equation. We are solving this differential equation. So, find the auxiliary equation, which is 2m minus 1. M plus 2 cubed is 0. So, 2m minus 1 is 0. So, m plus 2 is 0. Pero tatlong beses umuulit kasi the exponent is 3. So, sa dulo ko na lang isusulat kapag na-compute ko na yung root. So, the first one, m is 1/2. Sa pangatlo naman, sa pangatlo tuloy, dito naman, m is negative 2, but 3 times. Kung ano yung exponent niya, yun yung beses niyang umuulit. Okay, as a root. So, yung first one, this will give you a linearly independent solution, e raised to 1/2 x. And itong pangalawa, which has a multiplicity 3, e raised to negative 2x multiplied by x, and then you multiply by x again. Okay, so kailangan tatlo sila kasi tatlo yung root. Dito, isa lang kasi isa lang yun. And then the general solution, lalagyan mo lang ito na C1, C2, C3, C4, and then add all of them. Y equal to C1 e raised to 1/2 x, x e raised to negative 2x plus C4 x squared e raised to negative 2x. So this is the general solution. Okay, so let us compute this differential equation. Ito yung pinakamahirap sa lahat kasi napakaraming roots. So, sinadya ko talaga na marami siyang roots para ma-illustrate yung ng maigi yung ano natin, yung theorem natin. Okay? So, ang kailangan pala dito, kung hindi nyo ma-factor yung mga d's, gagamit kayo ng possibly rational root theorem. So, you should know how to compute polynomial equations in this case. Okay, dito kasi ang binibigay ko naka-factor na itong part na to, no? Para ma-illustrate kung ano yung paano sino-solve. Kasi ang lesson natin dito is not solving polynomial equations. Let us compute for the auxiliary equation or find the auxiliary equation. Ano na yun? So, replace d by m. So, d plus 3 raised to 2. So, yung m minus 1, m squared plus 4, and then, oops. Let us find the auxiliary equation. And how do you find the auxiliary equation? Replace d by m and then equate to 0. Diba ang dali kapag naka-D ano siya, D notation, differential notation. And then equate each factor to 0. So, si m minus 1 muna equal to 0. So, m is equal to 1. But it must appear 4 times because the exponent is 4. Okay? And next, this m squared plus 4 equal to 0. Tapos, m squared is negative 4. So, m is plus minus square root of negative 4. Or m is equal to plus minus square root of 4i. M is equal to plus minus 2i. Pero ang exponent ni itong factor na to ay 2. So, dalawang beses dapat lalabas tong plus minus 2i. So, dalawang 2i, dalawang negative 2i. And then, for the last one, m plus 3 equal to 0. So, m equal to negative 3, but twice siyang lalabas because the exponent is 2. Okay, so bigyan lang natin ng space ang bawat isa. So, hahanapin lang natin yung linearly independent solutions for each root. So, for the first one, it's e raised to 1x multiplied by x multiplied by x again and then multiplied by x again. Okay, stop na kasi ilan na to? 1, 2, 3, 4. 1, 2, 3, 4. And for this one, ano ang a natin? Ang a natin is equal to 2. Ang a natin is equal to, diba this is 0 plus minus 2i, 0 plus minus 2i. So, a is 0, b is 2. Ang k natin is 2. So, twice nag-a-appear ang bawat a plus bi tsaka a minus bi. So, ano yung form? A raised to 0x cosine bx, tapos times mo by x yan, e raised to 0x cosine 2x. So, ilan na yan? Dalawa, no? So, yun yung para sa k equal to 2, and then, you do that for sine. So, instead of cosine 2x, you have sine 2x na lang. Papalitan mo lang yung cosine 2x by sine 2x. Ayan. So, yan yung para sa part na ito, no? So, 1, 2, 3, 4, apat yun. And finally, for this case, e raised to negative 3x, tapos x e raised to negative 3x. So, stop na kasi dalawa na yon. And the general solution is, lalagyan mo lang C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, and then you add all of them. Why? Kailangan ko ng space kasi mahaba to. C1, e raised to x plus C2 to x plus C4 x cubed e raised to x plus C5. Yung e raised to 0, 1 na lang yun, no? Kasi e raised to 0 is 1. E raised to 0x is e raised to 0. So, meron tayong C5 cosine 2x plus C6 x cosine 2x. Next line ko na lang isusulat plus C7 sine 2x plus C8 x sine 2x. So, nandito na ako. Andito si C8. So, C9, C10 plus C9 e raised to negative 3x plus C10 x e raised to negative 3x. So, ang haba noong general solution niya. And ganyan mag-solve ng homogeneous linear differential equations with constant coefficient. Sana nag-gets ninyo itong lesson na to. So, yun lang. Goodbye and take care.